The probability density function of a random variable x is shown below. We want to find the constant a, write a mathematical expression for our PDF, and find the constant, or find the CDF for the case where x is between 0 and a. So let's start off with part A. PDF is what we're looking for, or it's what we're given. This is the probability density function. So this is PDF of random variable x. So in finding the constant a, we kind of need to write a mathematical expression for our PDF. To write a mathematical expression for it, we need to find an equation for our fx of x. So that's the first thing that we're going to do. We want to find for the f of x. This is going to be equal to what? Well, typically, it's going to start at like 1. And this is changing by the 0.4. So instead of having a 1, we're going to have 0.4 changing this. In parentheses, we are going to have that 1. Now, this is different. We have our minus. It's going to be going across this region, right? So it's going to be going across x depending on a. So we're going to have x over a. And this is going to happen as long as it's between 0 and a. Otherwise, so this is going to be equal to this or 0 everywhere else. So that's just our basis. We want to find the constant a. To find the constant, it's really easy now. All we need to do is integrate what we're given. We're going from 0 to a. We have this 0.4, which we can factor out front as 2 over 5. We have 1 minus x over a, and we're taking the derivative with respect to dx. Now, integrating this, we're going to have x minus x squared over 2a, and this is from a to 0. So plugging this in now, we have a minus, we're going to have this a squared over a, so we're essentially just going to have a over 2. Now, inside of here, we'll have 2a over 2. We'll subtract. This is just going to give us a over 2. Now these 2's are going to cancel out, and we're essentially going to have a over 5. And how do we solve for this? I kind of keep forgetting this, has been tried in the previous videos. We're solving for the area under here. Like, that's what we're looking for. An area is equal to 1. So this is going to be equal to 1. Can't forget that. So that's equal to 1, this is equal to 1, and of course this is equal to 1. That means the area for this is going to be equal to 5. And that's how we would get a. Now, for part B, it's going to be pretty similar. We're going to start over a little bit with integration-wise. Our f of x, this big F, is the derivative, right? And it's going to be equal to, where we integrate from 0, not to anywhere specific, but just to x. We're going to have f of x of a dA inside of here. We know that our f of x of a is just 0.4, 1 minus x over a, right? And so we've taken the derivative of this previously. It's just going to be a 0.4 if we leave it in the fraction, or the decimal form, instead of putting it in fraction. And then inside of here, we have our x minus x squared over a. Now, we know though that a is 5, right? So actually we're going to have x minus x squared over 2a. So we have x squared, 2 times a, which is 5, we're going to have 10. So this is essentially what we're going to be having. And this is going to be the answer to our problem. If we wanted to, we could factor our 0.4 in and fully write it out as, actually we'll write it down here. The uppercase f of x is equal to, again factoring this in, we have 0.4x minus, if we're dividing this, the decimal comes over here, decimal comes over here, we'll have 0.04x squared. And that's how we would solve for the CDF of this.